Guys, hello guys, how are you? This time guys, I finished my work and then instead going home, I'll stay back and explain what I'm doing today. I'm testing a VPL Parker stackable valve, a proportional control valve. V means valve, P means electro-hydraulic proportional, and L means low flow section. Okay, so I show you guys. I'm testing for the whole day because the setup is time consuming, and also I train my apprentice to build this M8 M6 variable motor. So it's busy. Okay, I show you what I did here, what I've done. Okay, this is 11 section VPL proportional valve. This one, each section has a pre-compensator. Okay, so I show you the cross-sectional of this valve. Okay, so I purposely cut this valve for training purposes. This is a spare, by the way. This is the compensator spool. So this is pre-comp because the function is and also the position is in the upstream of the metering orifice or spool. Okay, when it is post compensator means downstream. Okay, so this is the compensator spool, and then inside I remove the spring and shim just for this training purposes. This is the pressure limiter cartridge. This is the main spool here. Each section have a different type of spool, so meaning it has a different flow rating. Okay, so this one here is the mechanical adjuster to limit your flow. Okay, by the way, this is electro-hydraulic proportional control. So there's a solenoid here, and this one you can manually operated. Okay, so lever, okay, hand lever, and this one the port A and the port B. This is the working section relief valve. So B port and A port. So this is, by the way, the circuit, a simplified circuit. So this section here is the inlet section. It has a bypass spool which is proportional. This is the pressure reducing valve to control, to supply into your proportional solenoid, which is electro-hydraulic proportional. This is the load sense relief, so limit the LS pressure. Okay, and then this is the pre-comp spool, and then this will be your main spool or metering orifice. Okay, so like for example, if you're using a fixed pump for this setup, so you need a bypass. Okay, now because the fixed pump has no load sense regulator, so the circuit is kind like that. If you're using a load sense type pump, means the circuit here is changed. This will become, this line here will become the main pressure on the P. So if you're putting P there, this is your P, by the way. So that one connect straight here instead your load sense. Then the load sense now will connect to your pressure on your regulator of the pump. Okay, so that's the circuit. That's the difference of the circuit. So you still have the load sense relief to limit the load sense pressure, but the load sense signal will go to the pump. Okay, so this one here will be your P. It's a kind of a relief. Okay, so there's no bypass anymore, because the load sense type pump, when there is no actuation on the control valve, it will standby mode. Okay, now so going back here, so obviously I have my PWM supply, but my PWM problem is the minimum is 250 up to 800 milliamps. So I cannot control the flow proportionally. Also, this also I can only control the flow through lever. Okay, so I can get that minimum on the stroke. Okay, this is the P port. Okay, and then tank. This one here is the load sense. This will be my inlet section, because this inlet section has no bypass because of the setup in the machine. So the 11 spool and 8 spool is connected together. So the 8 spool valve has inlet bypass, which is this one, which is I use it for this testing, and that way I can bypass the flow if I'm using a fixed pump. Okay, so what I tried to give you information, guys, is how this spool works, and I got my A and B. Of course, I got P1, which is my P port, straight from the pump. P2 is my okay. So, hang on. So P1 is my straight from the pump. P2 is the load sense signal, and then the flow from A and B. Okay. Okay, this is my load, will be act as a load, so I use a relief valve, and then I can measure the flow rate. Okay, now remember, guys, the theory of the pre-comp is maintaining constant flow regardless of your load. Okay, that's the pre-comp to maintain constant flow. Now remember this spool here, the compensator spool has a spring and shims on my last video. So if the delta P change, the flow rate change as well, or if the flow rate change, the delta P change. So again, it's an orifice, so delta P across the orifice, so flow is proportional to your delta P. Now remember, the flow of the spool, as the stroke increase, the flow rate also increase. Okay, and also at the same time, guys, if you grab here, if you put a line here, as also the delta P. Okay, okay, so remember that theory. So here, as the flow increase, the delta P also increase. Okay, now spring rate curve, so X, and then force. As the force increase, it will also affect your stroke of the spring. Okay, Same here. So let's say this will be your shims behind the spring. So meaning as you increase the shim, it increase your force, and then to balance that, you need pressure from your hydraulic. So okay, so that's the principle. So remember pressure differential, P1 minus P2, that is considered from your load sense, from your pump, from your upstream minus downstream. Okay, so now because this is a pre-comp things, I'm gonna show you guys that regardless, I will change the load. Okay, let's say my command is 25%. Okay, regardless of the load, the flow will remain constant as long that the delta P is the same. Okay, now the pre-comp is a priority flow. Let's say you have 3 sections engaging together, demanding higher than the pump supply. So what happened, because it's a pre-comp, whichever is a less resistance or less load, that is the priority. Okay, the rest will not move, or it could be a little movement, but the principle of the pre-comp, if the pump supply is less than the demand, whichever is the less resistance of those section is priority. Okay, so pre-comp is a priority flow. The post compensator is flow sharing. So let's say the demand is higher than the supply of the pump, because the setup is post compensator. Now the flow now will divide according to the ratio, and then it will share to the 3 section or 3 or more section. So all the actuator will move, but very slow, because the flow is shared to the rest of the actuator. So that's the post comp and the difference between the pre-comp. Okay, now this going back to this, guys. Okay, so this is this area here, this one. Okay, this one is your P port, okay, which is your from pump, and then from there, okay, obviously because it's a pre-comp, it's normally open. Post-comp is normally closed, but this one is after the control valve, which is downstream. So when P spool, and then the flow will go in this gallery, and then from here, because it's closed, the spool is neutral. What happened? This one will close. Okay, then when there is a command from your solenoid, either A or B, let's say this one move. Okay, watch carefully. So the opening is here, not this one, because see this LAN here is still sealing. So this time now the flow will go up, it's closed, and it's open here. That's depend on the stroke movement, depend on the command. If it is half stroke, then the flow will give you only half. And then there's a signal here. This is a load sense signal through shuttle valve, and then that load sense signal will go straight to the bypass spool. And then let's say the command is 50 liters per minute only, then this pump will supply maximum 100 liters per minute. the 50 liters per minute, the half will bypass and the half will go to the actuator because the operator command only 50%. So what happened at the transition, because of the max, because of the 100, remember when the flow increase, delta P increase, because you have a delta P here from your pre-comp, which is set, let's say this one here is 13 bar, so it balance. Once that balance, the pressure here, okay, is getting rising. When that is rise, so what happen is this one here will push to the right and then bleed off the flow until the pressure from your P4 and P2 or P1 and P2 balance the spring, and then that will give you a 50 liters per minute because that is the command, and then the other 50 liters per minute is in the tank. Okay, so that's the problem of the fixed pump, because you always have a heat generation here because it's always relieving. Unlike the load sense type pump, the pump will automatically destroke and will give only 50 liters per minute because of the flow compensator on the regulator. Okay, now I don't want to explain that because I already explained that on my other video. Now I show you now here. Okay, I show you. Okay, I will use a manual thing. I will use this spanner here, and then see if I command 25%, 50%, and then I increase the load. The flow, you can see the flow there, and you can also see the differential pressure on here. So the differential pressure, okay, the differential pressure, guys, is depend on the shim on that spring, okay, or the force of that spring. Okay, so here there's a shim inside and plus spring. Okay, so all right, I will show you. I will start this. I will just wear my safety glass. Okay, wait. Okay, I will start. Hopefully it's safe. Now this is my load. I'm gonna bring it down to be safe. Okay, now this one 0. Okay. Okay. So I'm gonna increase the flow rate because I adjust this earlier. I'm gonna open this. Open. Let's see. That's the flow. I'm gonna engage solenoid. Now I have 18 liters per minute. I'm gonna make that 20. Okay, I'm gonna make it 20. Okay, I'm gonna make it 20. Okay. All right. So P1, P2. Okay. So I'm gonna put a load. So this one here, not much pressure differential because the flow rate input is very small compared to the maximum flow rate of the spool. So what I'm going to do, so that you can see the pressure differential clearly, I'm gonna use the spanner to do manually. Because remember, my PWM is not from 0 to 800 milliamps. Okay, I'm gonna zero that. So watch. So the pressure drop and then the flow gone. because there's no command. Now what happened? It bypass. Okay, and because I show you this one here, because this one, the pressure here is proportional to the force here, because there's no load sense signal, there's no LS signal here. So whatever the force of this spring, at the moment 15 bar, so that's it. Okay, so it's like an unload. Now watch the flow as I command maybe 5 liters. Okay, kind like that. So 35 minus 23, that's the differential pressure. Okay, so 35 minus 20, that's 15. So 13 bar. So 13 bar difference. I'm gonna increase the what's this, the load, and see what happened of the flow. Okay, I will maintain that 5 liters. I will not move the spool anymore, and then increase the load. Let's see if the 5 liters flow rate, let's see it become constant. Okay, wait. Alright, let's say I have 7 kind like that. Let's see the differential. What is that? I'm gonna go 50. Alright, that's still 13 bars differential. That differential and flow rate will remain as long that the differential pressure is maintained. Now remember, this is 20 liters per minute. Now the rest of the, let's say the 13, or this is 8, so the 12 liters per minute is in bypass. Okay, so watch the load. As I increase the flow, theoretically will maintain because of that pre-comb. See? So roughly 8 liters per minute. And then as you can see, as I vary the load, the flow rate will maintain because the delta P is maintained. So hopefully you understand, guys. It is very important the valve has a pre-comb so that the flow, the system will not affect by the load. So good, guys, so good. I can't go more because my motor is not enough power. So good. Now if I open all the way the spool, you cannot see the differential pressure. You cannot see the differential pressure because the spool maximum flow rate is more than 20 liters per minute, so it can handle. So see the differential pressure, not much because the spool has a maximum flow rate limit. So yeah. Now if I go neutral, so back to bypass pressure. Guys, you see guys how it works? The pre-comp VPL valve. So good guys. I really love it. I explain okay, watch the board and then just quick explain what happened there, okay? Let's say this one. This is the spool type, okay? So Q and then millimeters, that's the stroke travel. Obviously the spool start there, okay. Let's say this is your max. Okay, it's okay. It's alright guys. It's only for this. This is, let's say this is the max. Then 50%. Okay, so 100 liters per minute, 50 liters per minute, and then that's 25. Just for this training guys, okay? Now, of course, remember flow delta P across orifice. In here as well, if we put a graph, okay? That one there, that one there, that one there. Let's say this is bar. So 20 and then 15 and then 10. Okay? That's for that's value is just for this training purposes. Let's say if stroke is full but 20 bar delta P. Okay? So let's say command. All right, 100%. Okay, flow 100 liters per minute. Okay, delta P means from P to A or B. Okay, let's say 20 bar. Okay. Now, but the pre-comp spring, you know that pre-comp spring? This one. Normally open with it. When it's pre-comp, this one is spring. Okay? This one is 15 bar. Delta P only. Alright? So what happened is the flow will reduce because the limit is 15 bar only there on the pre-comp spool. Okay, the flow will reduce. Once the flow reduce, remember guys, flow rate is proportional to your delta P if you have a fixed pump. The flow will reduce, delta P will reduce until the what's this? The spring is balanced. Okay? Now, because this is only 15 bar, okay? 15 bar, so the flow will reduce and then the rest of the flow will bypass. Okay, what happened guys, instead of getting, let's put Q and then Q actual, pre-comp delta P 15. This is fixed bar. Alright, now because it's only 15 bar, you cannot expect 100 liters per minute. The actual, let's say 75 liters per minute. That 75 liters per minute, the delta P is 15 bar. So meaning here that one there, and then this is your spool. Okay, even that spool can handle 100 liters per minute, but because your pre-comb spool spring force is only 15 bar, then the flow reduce in order to balance that spring. Okay, that's the things that you're gonna watch when you design it. You make sure if the delta P between the load between here is 20 bar, make sure your pre-comb is more than. Okay, and that way you have enough flow. Because remember my last video, when you change the delta P on your pre-comb, the flow will change. Remember that? The delivery Q now is 75 liters per minute instead of 100 liters per minute. What happened? It has a wrong spool. Wrong spool because the delta P is too much. So remember here, 100 liters per minute, delta P is 20. Okay, it's actually either the wrong spool you choose or the shim is too less. Okay, in the graph, you're gonna check this in the data. If this spool here, let's say this is number 5, there's so many spool like that, and then this is number 3, and then there's another thing here, number 6. Let's say number 5. At number 5, the delta P at 100 liters per minute is 20 bar. Okay, that's the max. Now you have to choose the proper spool, or you're gonna increase your. The problem if you increase the delta P here is too much heat. 20 bar differential is too high. The normal, okay, this is recommended 10 to 18 bar. The lesser the delta P, the better, because not much heat. Okay, so you need to increase the pre-comb spring force, or you need to to change the spool type, which is, let's say this number 6 here, let's say 100, maybe 100 liters per minute, but the delta P is only 13 or 15. So that's okay, that's good. And that way you limit only your delta P to 15 liters per minute, your differential pressure. Okay, so hope you understand, guys. Remember, Q is proportional to your delta P. Okay, bye.